this video, we are going to be talking about the composition of functions. So we are going to be given two functions. In this case, f of x equals 3x minus 1 and g of x equals x squared minus 4. And we are going to find f of g, which is how that looks, of 7. So what that means is the first thing we are going to do is find what is in that blue rectangle's position. I need to find g of 7. What that tells me to do is go to my g function and replace its x with a 7. So if I do that, I have 7 squared minus 4, which gives me 49, minus 4, which gives me 45. So after I do that first part, this f comes down, and I am going to find f of whatever my last answer was, which was this 45. So now that means to go to the f function and replace its x with the 45. So when I do that, I will have 3 times 45 minus 1, which gives me 135 minus 1, which gives me 134, which is your answer. So again, you find what is in this spot first, the g of 7. Once you get an answer there, you plug that answer in to the other function, the f function. All right, in this next problem, my functions are f of x equals 4x plus 3 and g of x equals x squared minus 4x minus 5. And we are going to find g of f of 3. So the steps are the same. Doesn't matter, g of f, f of g, you are always finding what is in that position first. In this case, I am finding f of 3, which tells me to go to the f function and replace its x with a 3. So I'll have 4 times 3 plus 3, which gives me 12, plus 3, which gives me 15. Once I get to the end of that, I drop down what is in that front position, which is the g, and you are going to find g of your last answer, which was 15. So that's telling me to go to the g function this time and replace its x's with 15s. So if I do that, I will have 15 squared minus 4 times 15 minus 5. 15 squared is 225 minus 4 times 15 is 60 minus 5. So 225 minus 60 minus 5 gives me 160. All right, this next example, I'm doing the same thing. Given two functions, the first thing I'm going to find in this problem is g of negative 1, which tells me to go to my g function and replace its x with a negative 1. So I will have negative 1 to the third power, which just gives me negative 1. So I'm done with the first step. I will bring down this f, and I am finding f of that last answer, which was negative 1. So that tells me to go to my f function, and I'm going to replace its x with the -1. So I have 6 times -1 plus 7. 6 times -1 gives me -6 plus 7, and -6 plus 7 gives me 1. All right, in this next one, again, I'm given two functions. F of x equals x plus 13, g of x equals x minus 13. This time it wants me to find f of g of x. So what this says is to go to the g function and replace the x with an x. In other words, do not change the g function at all. G of x equals x minus 13, and that's as far as I can take that first step because those terms do not combine. So I'll move to the next step, which is to bring down the f, and just like the last ones, you're gonna put that last answer, x minus 13, in the parentheses. So what that's telling me is to go to my f function, and you're going to replace the x with what is in that parentheses, which is x minus 13. So instead of writing x plus 13, I replace the x with x minus 13, and then have the plus 13. And that minus 13 and plus 13 just cancel, so I am just left with x. On this problem, they're also going to want you to find it the other way. So here we've done f of g of x, and now we're going to find g of f of x. So same thing, I'm just going to find f of x first. So it tells me right here what f of x equals. It tells me that f of x equals x plus 13. So I'm done with that step because I can't go any further. So I'll bring down my g and put in parentheses what you got on the last part of the answer, which was x plus 13 this time. So this tells me to go to the g function, and I am going to replace this x with x plus 13. So you take the x all the way out and put in its place x plus 13, and then you have the minus 13. And again, that plus 13 and minus 13 cancel, so you're just left with x. Now, you're also going to be asked to find the domain of each of these. So remember, when you're talking about domain, you want to find restrictions, which for the most part, the restrictions that we have been dealing with come in the denominators of fractions because your denominator cannot equal 0. So when I am looking for the domain of f of g of x, I look in two places. I look at the actual answer, which is x, and then I look at what I plugged in on the last step to get to that answer. I look for restrictions in both of those places. I do not see any restrictions. X can be anything, and so can x minus 13. So your domain in interval notation is going to be negative infinity to positive infinity. Same thing on the domain of g of x. Again, the two places that you look are the final answer, which was just x, and what you plugged in to get the final answer, which was x plus 13. So once again, no restrictions, so your domain would be negative infinity to positive infinity. All right, on this next example, we are going to start off by finding f of g of x. So once again, we start off in the same position. Whatever is in the blue rectangle, which is g of x in this case. G of x, it tells me what it is in the problem. It tells me g of x equals 5x squared minus 4x minus 1. And once again, that's just as far as I can take that first step, because none of those terms can combine. So I go ahead and move to the next step, which is to bring down that f, put in parentheses what your last answer was, which was 5x squared minus 4x minus 1. So now what we are doing is we are going to the f function. We're going to take out its x and put in the 5x squared minus 4x minus 1. So going to going to the f function. I'm going to take out this x and replace it with what is in the parentheses. So I will have 5x squared minus 4x minus 1 in place of the x, and then I'll have the plus 1 that comes after that. So now I do have a little bit of cleaning up I can do, because that plus 1 and minus 1 cancel each other out. So I am left with 5x squared minus 4x. That is f of g of x. Now I'm going to go ahead and find the domain of this composition. Remember the two places that you will look. You will look at your final answer for any restrictions there. There's no restrictions because you can square any number and you can multiply any number by -4. There's no restrictions there. And you also look for restrictions at what you plugged in on that last step. So the two red rectangles are where you are looking for restrictions, and neither one of those have restrictions, which means your domain is negative infinity to positive infinity. Now we're going to do it the opposite way. We found f of g of x and its domain, and now we are going to find g of f of x and its domain. So the first thing we find this time is f of x. Well, it tells me that f of x equals x plus 1. That's as far as I can take that step. So now I will bring down the g, and I am finding g of that last answer, which is x plus 1. So now I am going to the g function, and I am going to replace the x's with the x plus 1s. So I will have 5. Replace the x with x plus 1 squared. Minus 4. Replace the x with x plus 1 minus 1. So I've rewritten the g function, replacing the x's with x plus 1s. Now I need to take care of that x plus 1 squared. So I will just do this up here out of the way. So x plus 1 squared means to multiply x plus 1 times itself, and then I'll FOIL. X times x gives me x squared. Outside is x times 1, which is 1x. The inside is another 1x. And then my last 1 times 1 is 1. When I combine the like terms in the middle, I will have x squared plus 2x's plus 1. So that's what I have for the x plus 1 squared. So I'll just bring down the 5. X plus 1 squared ended up being x squared plus 2x plus 1. Now I can distribute the 5. So now I have 5x squared plus 10x plus 5. I can distribute the negative 4 to remove those parentheses. So I'll have negative 4x minus 4, and then just drop down the minus 1. Now we can clean this up by combining like terms. There's no other x squareds besides that 5x squared. But I can combine this 10x and that minus 4x, which gives me positive 6x. And when I combine the constants, the 5, the minus 4, and the minus 1, I'm not left with anything because 5 minus 4 minus 1 is 0. So this is g of f of x. Now finding its domain. Just like the previous ones, there's 2 places that you look at your final answer for restrictions and what you plugged in to get your final answer for any restrictions there. Since I don't see any restrictions in either of those red rectangles, your domain, once again, would be negative infinity to positive infinity. All right, last example. F of x equals 2 over 1 minus 9x, and g of x equals 1 over x. So first, we are finding g of x. So g of x equals 1 over x. That's as far as I can take that step. So I move to step 2, and I am finding f of your last answer, which was 1 over x. So what this means is we are going to the f function, and we are going to replace its x with a 1 over x. So I will have 2 over 1 minus 9. Instead of x, I'm going to have 1 over x. So now we need to simplify this. So 2 in the numerator. Now, what I'm doing in the denominator, I'm just going to bring over the 1. I have minus 9 times 1 over x. So I'm going to think of it as minus 9 over 1. So when I multiply, I just go straight across in the top and bottom. So I'm going to have minus 9 over x. So this fraction is too complicated because there is a smaller fraction within a larger fraction. To fix that, I am going to look at this fraction 9 over x. I'm going to multiply the numerator and the denominator by that denominator of the smaller fraction, which is x. Because here's what's going to happen. Up top in the numerator, I have 2 times x, which will just give me 2x. Now, when I multiply the bottom, both things by x, the first thing I have is the x times 1, which just gives me x. Now I'm going to have minus, when I multiply the x times the 9 over x, The x's actually cancel there, so I am just left with the minus 9. So that is f of g of x. So now we are going to find the domain of f of g of x. So remember the two places that you look for restrictions. The final answer, which I do have a restriction because there is an x in its denominator. That means that denominator, which is x minus 9, cannot equal 0. So to find what makes that happen, I will add the 9 to both sides. So this tells me that x cannot equal 9. And the other place that you look is what you plugged in to get that last answer, which is the 1 over x. Its denominator also can't equal 0. And its denominator is just that x. So x cannot equal 9, and x cannot equal 0. Let's look at what this looks like in interval notation. I'm going to put both restrictions on my number line in the order that they come, which would be 0 first, and then 9. And then here's your 3 intervals. Negative infinity to 0 in union with 0 to 9 in union with 9 to infinity. And now we will find it the other way around. So we have found f of g of x. Now we are going to find g of f of x. So f of x comes first. F of x is 2 over 1 minus 9x. And again, that's as far as I can take that because that doesn't simplify. So I'll go to the next step, which is to find g of your last answer. So I'm just bringing down the 2 over 1 minus 9x. So what this is telling me to do is to go to my g function, replace its x with what is in that parentheses. So I will have 1 over, replace the x with 2 over 1 minus 9x. Now, just like when we were finding the composition the other way around, I ended up with a fraction that is too complicated. So remember how we fixed that in the last one. I'm going to multiply the numerator and the denominator by the denominator of that smaller fraction, which is 1 minus 9x. So in the numerator, when I multiply 1 times 1 minus 9x, I just get 1 minus 9x. In the denominator, and this is why we used it, the 1 minus 9x cancels, so all I am left with is 2. So that is g of f of x. And now we will find its domain. Looking in two areas, your final answer does have a denominator, but you'll notice the denominator is just 2. That means there's no x in the denominator, so there's not any restrictions. But the restriction comes where you plugged in, which is 2 over 1 minus 9x. It does have a denominator with an x in it. So that denominator, which is 1 minus 9x, cannot equal 0. And then we'll solve this for the x. So So we'll subtract the 1 from both sides. So negative 9x cannot equal negative 1, and then divide by negative 9. So x cannot equal negative over a negative, makes it positive 1/9. So that's your only restriction on your number line is 1/9. So your intervals are negative infinity to 1/9, in union with the other interval is 1/9 to positive infinity.